Alright, so I think I'm recording. Let's take a look more. And I just realized I did a video for problems 1 and 2, and I don't think that I answered all of the questions. I did not indicate whether the function was even, odd, or neither. Even, odd, or neither, if we have a graph, is determined by symmetry. And students do very well on it. So even though I forgot to answer it, I think that you'll be fine. But let's go back real quick. Here I see, let's clear my work from before. If I focus my attention on the y-axis for just a moment, I have symmetry with respect to the y-axis. What we mean by that is the right of the y-axis is a mirror image of what's left of the y-axis. So any point here that's here is reflected in the mirror directly across. Where the distance to the right is 3 units, the distance to the left is -3. Well, we don't have the direction is negative. To the left is negative, to the right, I shouldn't say distance because we don't have a negative distance. So where this x-coordinate and this x-coordinate are equal and opposite. This is +3, that's negative. Now, the y-coordinates are always both the same for points of symmetry. So we say that this point has been reflected across the y-axis. And if that's true for all of the points on the graph, then it's an even function. Alright, and if it's an even function, it can't be both even and odd at the same time. Alright, so we look here at a graph that's pretty similar. When we're looking for even and odd and we talk about symmetry, there are other types of symmetry. I do see symmetry in this graph. I can see that this graph is symmetric across the line x equals 2. But that's not the y-axis, so it's not an even symmetry, even though I can see that the right-hand side is a mirror image of the left-hand side. That does not mean that it's an even function, because this axis of symmetry has to be the y-axis. So I can definitely tell that this is not an even function. So the question is it an odd function? It does pass through the origin, and odd functions will pass through the origin. With odd functions, the symmetry is a rotational symmetry about the origin. Let's copy this graph. If you put your pencil on the origin and rotate the graph 180 degrees, if you get the same picture, it's an odd function. Well, you can see that this kind of, well, this area is opening upward and this area opening downward, that this is not an odd function. So if it's not even and it's not odd, then we say it's neither. So I apologize for not answering both of the questions, and I think I made a mistake while doing 2. I corrected it, but off to a great start. Well, sorry about that. Let's go down and do problems 3 and 4 and try not to make any mistakes and to try to answer all the questions. Read the directions. That's what they always used to tell me. Alright. We were using green to highlight areas where the function is decreasing. As I'm moving to the right, I'm having to go down. Now when that changes, as I'm moving to the right, if I have to go up, that portion of the graph is increasing. I hit here and I'm going to have to start going down, so it's decreasing. So the function is increasing where it's yellow. Let's describe, use the endpoints of the interval, and we use the x coordinates. So this point has coordinates -2, -5. Now you see that looks, writing the coordinates of points in 2 dimensions and writing our intervals looks like the same notation. So the only way to understand the difference is to understand the context of the problem. Here we're starting at -2. Now up here it is 2 to 5. I'm interested in the x coordinate. So this function is increasing for x between -2 and +2. As if you pick any 2 points where the x coordinates are between -2 and +2, then I guarantee you that as x increases, that y will also increase. Alright, what about decreasing? Well, it's happening over 2 intervals, so we'll need a union. When we have an arrow in our graph, it tells us 2 pieces of information. Information about the y coordinate, information about the x coordinates. To the left, these x's are negative infinity and these y values approaching positive infinity. Here, this graph, the endpoint, that the arrow there is telling us 2 informations. The x coordinates are heading to positive infinity and the y coordinates to negative infinity. So as I come in from the graph from the left, the first thing I hit is this arrow, and we always write our interval notation, a smaller number comma a larger number, and it doesn't get smaller than negative infinity. When I move to the right, it's decreasing all the way until I hit an x coordinate of -2, and then it changes and to something else, in this case increasing. And that can, then it starts, there's a change where it goes back to decreasing if you pick any 2 points that are larger than 2. Any 2 points that have it, when I say large, let me rephrase that. Any 2 points that have an x coordinate that is larger than 2. As I move to the right, the y coordinates, the y values are decreasing. So like I say, if you found the slope between these 2 points or between any 2 points in this region, for all the points in this region, it's decreasing. The slope is negative. And constant, well, there's no horizontal portion of the graph, so we can use our empty symbol. We can say never, we can say nowhere. We just don't want to leave it blank just because it's never constant. Leaving it blank may indicate that you don't understand or not fully aware of the concept. Here, we're answering it. Let's take a look at number 4. Oh, I did it again. I forgot to answer whether it's even or odd. Alright, so let me erase the scratch marks that I have here. Well, my answer, remember these were my answers. Well, increasing, decreasing, constant, and now I have to remember, hey, we've got to answer whether the function is even or odd. And does it have symmetry with respect to the y-axis? Well, no, the left-hand side is not a mirror image of the right-hand side with respect to the y-axis. It's not an even function. Does it have symmetry with respect to the origin? And that's a rotational symmetry. If I rotate it 180 degrees, now here it looks like it is. The height above the y-axis here, 5 units, the height above 5 units. Yeah, everything, it has symmetry with respect to the origin. It's passing through the origin. It has symmetry with respect to the origin. Now, in if we pick any point on the graph, it doesn't matter what it is. Here it's 2, 5. If both the opposite of x and opposite y is also a point on the graph, for all points, it's an odd function. The opposite of 2 is negative 2. The opposite of 5 is negative 5. Negative 2, negative 5 is a point on the graph. Now, we have to be careful. Sometimes there may be points where that's true, but it has to be true for all points. If you pick any point on the graph, now I'm just picking ones where I can easily read the coordinates. It's going to be true even for decimal value, but for 5, negative 4, negative 5, positive 4 has to be on the graph if it's an odd function. And like I say, that has to be, you pick any point x and y, and the opposite of x and the opposite of y are going to be on the graph somewhere. Alright, so this is an odd function. Alright, now I believe I've answered everything with problem 3. What about with problem 4? Alright, as I come in from the left, the first thing I hit in the graph is the arrow. The arrow is giving us two pieces of information. Information about y, information about x. As we leave the graph, the last thing we hit is the arrow. It's giving me information about x, the information about y. Let's use yellow for increasing. When I hit that arrow, as I move from point to point, as I move to the right, I'm going up, so the y values are increasing. So we say on this interval the function is increasing, and that continues to happen until I hit this maximum point right there, and then it changes and I begin to go down as I'm moving to the right. So the function is decreasing here until I hit this point, and then it continues. Then it changes to increasing, and it continues to increase all the way forever. Alright, so we have two intervals where it's increasing, so we're going to need to use the union. On the left here, the arrow, the x values, I'm coming from negative infinity as I move to the right. Smaller value, comma, a larger value. When I get to this point, the x coordinate is a negative 3. I'd have to eyeball the y coordinate. I don't even know what it is, but I don't need to really know what it is in my answer, so that's why I didn't bother writing the coordinates of the point. I just came down here and read the x coordinate. Or a union, this interval, union this interval. So the x coordinate at this point is 3. As you move to the right, any 2 points as you move to the right that are greater than 3 have x coordinates greater than 3. The y values, as x increases, y will also increase, and that will happen forever to the right of 3. So this function is increasing over these two intervals. The function is decreasing over the interval that I've shaded in green. So the x coordinate here is a negative 3. And as you move to the right, any 2 points that have an x coordinate that is bigger than negative 3 yet smaller than positive 3, as x increases, y will decrease. That happens all the way up to 3. This function is never constant, so we can indicate that, if you'd like, by an empty set. Alright, so let's stop there and I'll do the next pair on another video. And again, I'll try to answer all the questions. So hey, let's answer whether it's even or odd. Why do I keep doing that? Alright, I'm going to erase this. It is not an even function because with respect to the y-axis, the left side and the right side are not mirror images of each other. If we put our pencil on the origin and we rotate it 180 degrees, do we get the same picture? Now, we do have to be careful that sometimes it'll almost look like the same shape. You've got to make sure that if x and y is on the graph, that the opposite of x and opposite of y are on the graph for all points on the graph. But there's definitely key points that we look for. Here at -3, it's just under 4. Here, left 3 units, it's just under the 4 units, so that's looking good. It is going through the origin, so an odd function has to be going through the origin. And then at 3 over here, you're down to, I don't know, -3.6 or whatever that is. And if you go to the right 3 and down 3.6, you're on the graph. So to me, this definitely looks to be an odd function. Alright, so I hope that helps.